Hello everyone, in this video we will learn about deadlock detection. We have already seen there are 4 strategies for dealing with deadlock. Out of that 4, this one is the second strategy, that is deadlock detection and deadlock recovery. So first of all, let us see what is deadlock detection. So first one is deadlock detection for a single resource, that is single type of resource. So here in this figure, these square are nothing but a resource. So R, S, W, U, T and V, these all are resources. This circle is nothing but a process, that means A, C, F, D, G, E and B, these all are nothing but a process. And these all, whether it is a resource or process, are known as node. So these all are nothing but nodes. R, A, whether it is a process or it is a resource, these all are nodes. And if the arc, these all are nothing but arc, this one is again arc. If your arc is moves from resource to process, means this resource is held by this process. If your arc moves from process to resource, means this process is requesting to this resource. Now we are detecting a deadlock for this figure. So right now initially we are starting from node D, that is this D node. Now what we have to do, we have to create a list and find out that whether there is any node that is repeated in our list. If a node is repeated, then there is a deadlock. Now how to create a list? Let us see. Initially we are starting from node D. So before starting, our list is empty, means we are having empty list. There isn't any node in our list. Now once we start from node D, add this node into our empty list. So our empty list becomes D. Now check, this D node is repeated in our list. No, it's only one time. So it's not repeated in our list. That's why. So right now deadlock is not created. Now find out from this node, that is from D, how many outgoing arcs, that is from D to T and D to S. So we will consider towards right side only. We are not considering towards this side. So we are considering this T, means towards right hand side, that is T. So there is one outgoing arc, that is from D to T. So add this T into our empty list. So our list becomes D and T. Again check. Again we have to check whether any node is repeated in our list. If repeated, then there is deadlock. Otherwise still there is no deadlock. So right now no node is repeated, so still there is no deadlock. Again from T, how many outgoing arcs? That is only one outgoing arc, that is from T to E. So again add E into this empty list. So list become D, T and E. Again from E to V, there is one outgoing arc. So we just add D, T, E and V. Still no repeated node. Then after from V, there is one outgoing arc, that is V to G. So our list becomes D, T, E, V and G. Again from G, there is one outgoing arc, that is G to U. So again we have to add D, T, E, V, G and U. Still there isn't any node that is repeated in our list. So still no deadlock. Now from U, there is one outgoing arc, that is U to D. So after reaching over here, our list become D, that is D. Then after outgoing T, so T. Then after T to E, so E. Then after E to V, so V. Then after V to G, so G. G to U, so U. And U to D, so D. Now check in this list, there is one repeated node, that is D. So here circular chain created. So here deadlock is detected or deadlock is created. So this portion there is deadlock. So in this way deadlock is detected for a single resource. Now let us move further. How deadlock can be detected for a multiple resource. More than one resource of same type, means there are 4 tape drives, there are 2 plotter, there are 3 scanner, there is 1 CD-ROM. Means there is more than one resource of same type. So here E equals to total number of each resource in our system. There are 4 tape drive, 2 plotter, 3 scanner and 1 CD-ROM. Then after C equals to number of resources held by each process. There are 3 processes P1, P2 and P3. So P1 hold 0 tape drive, out of 4 tape drive 0 tape drive. P1 hold 0 plotter, P1 hold 1 scanner, P1 hold 0 CD-ROM. Same way P2 hold 2 tape drive, P2 hold 0 plotter, P2 hold 0 scanner, P2 hold 1 CD-ROM. P3 hold 0 tape drive, P3 hold 1 plotter, P3 hold 2 scanner and P3 hold 0 CD-ROM. So this C is equal to number of resources held by each process. Then after A equals to number of resources that are still available after holding this process, that is C. So A equals to E minus C. So if we consider tape drive, out of 4 tape drive, 2 tape drive is held by this process P2. So 4 minus 2, that is 2. Plotter, out of 2 plotter, 1 plotter is held by P3. So 2 minus 1, that is 1. 3 scanner, out of 3 scanner, 1 plus 2, 3 scanner is held by process P1 plus P3. So it's 0. Same way CD-ROM, out of 1 CD-ROM, 1 CD-ROM is held by process P2. So it is 0. Then after R equals to number of resources still needed by each process to proceed. So process P1 required still 2 tape drive, 0 plotter, 0 scanner and 1 CD-ROM to proceed. Process P2 requires 1 tape drive, 0 plotter, 1 scanner and 1 CD-ROM to proceed. Same way process P3 requires 2 tape drive, 1 plotter, 0 scanner and 0 CD-ROM to proceed. Now let us execute each and every process one by one. First of all, let us see process P1. Here process P1 requires 2 tape drive and 1 CD-ROM. Here all these processes can access or can take resource from these free resource only. So here this process require 2 tape drive. It is available? Yes, it's available. Process P1 requires 1 CD-ROM. Is it available? No. So this process cannot proceed because this 1 CD-ROM is not available in free resource. Now let's take another process, that is P2 required 1 tape drive, that is available, but 1 scanner, that is not available, and 1 CD-ROM, that is again not available. So these 2 resources are not available. So again this process cannot proceed further. Next process P3. It requires 2 tape drive, that is available, 1 plotter, that is also available. So this process P3 can proceed. So these 2 tape drive is allocated to process P3 and 1 plotter is allocated to this process P3. So here once this 2 tape drive and 1 plotter is allocated to this process, this number of free resources becomes 0 0 and 2 becomes here 2 and 1 is added into 1, so it becomes 2. Now once this process is completed, this all the resource become free and this resource is added into these free resources. So after completing process P3, these 2 tape drive becomes free, 2 plotter becomes free and 2 scanner becomes free. So it becomes 2, 2 and 2. Now process P3 over, so we have done it by days. Now again this process P1 requires 2 tape drive, that is available, 1 CD-ROM, that is not available. Same way process P2 that requires 1 tape drive, that is available, 1 scanner, that is again available, but this 1 CD-ROM is not available. So both of these processes cannot proceed. So here deadlock created. So in this way we can detect a deadlock for a single resource as well as multiple resources. Thank you very much.